Hello, my dear student. Today I'll discuss one of the most interesting topic and I'll solve some problem from here. Linear transformation is also very interesting topic. Linear transformation. The question is a transformation t colon r cube to r square is defined as t xyz is equals to xyz comma 2x minus y plus 3z, so that this t is a linear transformation. So already you know, if you want to prove that this t is a linear transformation, then we need to prove t alpha plus beta is equals to t alpha plus t beta, and t c alpha is equals to c t alpha. These are the two conditions you need to prove it. Okay, so first you need to write solution. It's very simple. The given transformation is, whatever the transformation is given, you need to write down t x y z is equals to x plus y plus z comma 2x minus y plus 3z. So this is the first step. Okay, please write down this number, equation number 1. So here we need to prove these two conditions. Okay, so please write down let alpha is equals to x1 y1 z1 from v, that is this one. So here basically v, this is your domain is r cube, that three-dimensional. Okay, so if your alpha is coming from this, that means this alpha should satisfy this relation. So you may write therefore uh, t alpha is equals to t x1 y1 z1 is equals to x1 plus y1 plus z1 comma 2x1 minus y1 3z1. Okay, now this is number equation number 2. Clear? Next is you write the and beta, you want to consider beta is equals to, that is your x2 comma y2 comma z2 from r cube. So same way t beta is equals to t of x2 comma y2 comma z2 is equals to, from the relation you may write, that is coming x2 plus y2 plus z2 comma 2x2 minus y2 3z2. Is it clear? This one. Okay, so this is number equation number 3. Okay, so please write down now alpha plus beta, which is nothing but alpha plus beta is equals to how much? x1 y1 z1 plus x2 y2 z2. So basically it is coming x1 plus x2 y1 plus y2 z1 plus z2. Okay, so if you consider, basically if you add the next new value is coming, maybe new value will come. So here you may write x3 comma y3 comma z3. So here we have considered this, basically it is consideration, that is late this one, that means you are considering x1 x2 is equals to x3, y1 y2 is equals to y3, and so on. Correct? So now we need to prove that this alpha plus beta satisfy this t alpha, that is we need to prove t alpha plus beta is equals to t alpha plus t beta. We need to prove it. Okay, so please write down. So therefore t alpha plus beta is equals to t x3 comma y3 comma z3. Now we are satisfying t with this coordinates or vector. So ultimately you have x3 plus y3 plus z3 comma 2x3 minus y3 plus 3z3. I think it is clear to everyone. Is it clear? Now we have to expand it. How to expand it? Please listen carefully. Now you have this. So now what is your x3? Already you know what is your x3? x1 plus x2. So please write it down. That is x1 plus x2 plus y1 plus y2 plus z1 plus z2. Clear? Is it clear? Okay. Comma 2x1 plus x2 minus y1 plus y2 plus 3z1 plus z2. Clear? So now we want to separate it. So here you may write x1 plus y1 plus z1 plus x2 plus y2 plus z2 from here, and from here 2x1 minus y1 plus 3z1 plus 2x2 minus y2 plus 3z2. Okay, that is component wise you have rearranged. So from here if we can write, that is x1 plus y1 plus z1, okay, comma 2x1 minus y1 plus 3z1. That is first component comma first component plus second component comma second component. So here you may write x2 plus y2 plus z2 comma 2x2 minus y2 plus 3z2. Clear? So now from here it is clear. This, what is this? Basically from equation number 2. What is equation number 2? Please check. Equation number 2 is coming T alpha. This expression is T alpha, isn't it? So please you can write down T alpha from this one. You just to check, this one is a T beta. So T beta. So you can write down using 1, 2 and 3 condition. So our first condition is satisfied. Therefore, T alpha plus beta is equals to T alpha plus T beta. So first condition is satisfied. First condition is satisfied. Clear? So here your main task, after getting the value or from the given relation. So first you have to substitute the x3 is equals to x1 plus x2, y1 plus y2, z1 plus z2. Then you separate one component x1 plus y1 plus z1, x2 y2 z2 separately, same from this part also. Then one component, that is x1 y1 z1, and here also x1 z1 you write as a coordinate form. Okay, now so first proof is over. Now come to the second proof, and also you want to prove TC alpha. What is TC alpha? Basically T C x1 y1 z1. Basically T C x1 C y1 C z1. So from here it is clear, that is already we need to satisfy this relation also. This relation must be satisfied with this coordinate. So here you may write C1 Cx1 plus Cy1 Cz1 comma 2Cx1 minus 2 Cy1 plus 3Cz1. So from here you may write, if you take common, is coming x1 plus y1 plus z1 comma 2x1 minus y1 3z1, basically ct alpha, using equation number 2. So from here it is clear tc alpha is equals to ct alpha. Okay, so that means both conditions are satisfied. Number one condition, T alpha plus beta is equals to T alpha plus T beta, and T C alpha is equals to C T alpha. So you write down hence the given transformation, the given transformation T x y z is equals to x plus y plus z comma 2x minus y plus 3z is a linear transformation. Okay, so this is a proof. Very simple. Clear? So we need to prove both condition T C alpha, T alpha plus beta is equals to T alpha plus T beta, and T C alpha is equals to T C T alpha. Now we are going to solve another interesting question from here. Another question. Now please try to understand. Question number 2. A transformation T colon r cube to r cube is defined as Txyz is equals to x plus y, y plus z, z plus x. Prove that T is a linear transformation and also find its inverse. That means inverse linear transformation you need to calculate. So here this portion is extra. So already you know how to prove linear transformation. Okay, same process you continue, that is solution. So please write down the given transformation is, please write down T x y z is equals to x plus y, y plus z comma z plus x. This is number 1. So what is our proof ultimate objective? Our objective to prove alpha plus beta is equals to T alpha plus T beta, number 1. Number 2, T C alpha is equals to C T alpha. Okay, we need to prove these two conditions. Okay, so write down let alpha is equals to x1 y1 z1 is equals to x1 y1 z1 belongs to r cube. That means this one, that is a domain. So therefore T alpha is equals to T of x1 y1 z1 is equals to, you may write x1 plus y1 plus z1 plus x1. This number equation number 2. Clear? Same process. And beta is equals to x2 y2 z2 belongs to r cube. Okay, so same way we may write T beta is equals to T of x2 comma y2 comma z2 is equals to x2 plus y2 comma y2 plus z2 comma z2 plus x2. So this is equation number 3. Clear? Now we need to prove this. Clear? Very easy. So next line you write down. So now alpha plus beta is equals to how much? x1 comma y1 comma z1 plus x2 comma y2 comma z2 is equals to x1 plus x2 comma y1 plus y2 comma z1 plus z2. Clear? So here we have considered x1 plus x2 is equals to x3 comma y3 comma z3. Let. Okay. So now we need to prove. So therefore T alpha plus beta is equals to T of x3 y3 z3. So from here we may write x3 plus y3 y3 plus z3 comma z3 plus x3 formula wise. Okay, so now we need to substitute the value of x3 y3 z3 value from here. So from here we may write x1 plus x2 plus y1 plus y2 plus z1 plus z2. Okay. No, it is not correct. Now basically x3, that is your x1 plus x2 plus y1 plus y2 comma y1 plus y2 plus z1 plus z2 comma z1 plus z2 plus y1 plus uh, x1 plus x2. Okay, so now you component wise, first component wise x1 y1 z1 you separate this. So from here we may write x1 plus y1 plus x2 plus y2 comma y1 plus z1 plus y2 plus z2 comma z1 plus x1 plus z2 plus x2. Clear? That is x1 y1, that is one component just you take as a sim form. Okay, now you can see, so first component comma first component comma first component. So from here we may write x1 plus y1 comma this one y1 comma z1 second component, that is z1 comma z1 plus x1 plus x2 plus y2 comma y2 plus z2 comma z2 plus x2. Okay, basically this one comma this plus this one comma this one comma this one. Okay, so basically it is nothing but T alpha plus T beta. This is your T alpha and this is your T beta. So it is coming using equation number 2 and equation number, clear, these two. Okay, so first condition is satisfied. Now come to the second condition. What is your second condition? That is TC alpha. TC alpha. We need to prove C alpha is equals to CT alpha. Okay, so T C, that is your x1 y1 z1 is equals to T Cx1 Cy1 Cz1. So formula wise you may write that is Cx1 plus Cy1 Cy1 plus Cz1 formula, that is a transformation relation. Cz1 plus Cx1. So from everywhere you can calculate, you can take outside C, it is coming C x1 plus y1 comma y1 plus z1 comma z1 plus x1. So basically it is nothing but C T alpha using equation number 2, where C is a constant. Okay, so therefore T alpha plus beta is equals to T alpha plus T beta, and here you have proved T C alpha is equals to C T alpha. So that in both conditions are satisfied. So hence the transformation T that is x y z is equals to x plus y comma y plus z comma z plus x is a linear transformation. Linear transformation. So first part is over. We need to calculate the inverse. Okay, it's very simple, it's very easy. Okay, clear? Okay, that is the second part. There is a second part of it, that means find T inverse. Okay, so now basically T inverse means what? The inverse function. So here it is r cube to r cube. So here x, basically it is a tx. If I consider alpha, T alpha, we need to calculate. Suppose if I can consider it is a y, okay, or y, then it will be alpha is equals to, from here you may write alpha is equals to f inverse y. So that means we need to calculate one relation in terms of y, that is called f inverse. Now let's see. So please write down the given transformation. The given transformation is, so already you know T x y z is equals to x plus y plus z, and z plus x. Clear? So this relation is given. So now you write down let x plus y is equals to u, or you may write p y plus z is equals to q, and z plus x is equals to r. So what is our target? Our target to find x, y, and z in terms of p, q, r. Is it clear? So now our objective to find x, y, z in terms of p, q, r. So when you consider x, y is equals to p and q and r, so therefore you may write t x y z is equals to p q r. Is it clear? So therefore, so our objective, so basically, so you can write down, therefore from here you may write t inverse p q r is equals to x y z. Clear? X y z. Now our objective from here, from these three conditions, number 1, number 2, and number 3, we need to calculate x y z. When I substitute the value x y z to this relation, that will be the required inverse relation. Clear? So first you have to write down the given transformation, then you write down how many number of terms you have. You need to consider p q r, okay, or maybe p q. If it is a double variable, you may write p q and so on as per the codomain part. Okay, so here we have p q r. Now we have replaced by p q r. So when you're taking the inverse of it, it is coming T inverse PQR is equals to XYZ. So from here it is clear that inverse function is in terms of PQR variable. So we need to replace XYZ. How to replace? From these three equation, these three relation. We need to solve these three relation and to find the value of X, Y and Z. Okay. So now you write down. So this is our main target. If I get the value XYZ, substitute and find the result. Okay, that is, you may consider that is the equation of number 4. Clear? So please write down now. So please write down now. X plus Y is equals to P, Y plus Z is equals to Q, Z plus X is equals to R. So already you have considered this is the equation number 1, equation number 2 and equation number 3. If I can add 1 plus 2 plus 3, ultimate objective to eliminate, okay, X, Y, Z ultimately is a very known question. So if I add all together, it will be 2 of X plus Y plus Z is equals to P plus Q plus R. So from here we may write X plus Y plus Z is equals to P plus Q plus R by 2. Okay, so basically if I can consider this is number 5, already 4 I have considered. So if you can write 5 minus 1, so ultimately 5 minus 1, xyz minus xy, it will be z. What will be the z value? P plus q plus r minus by 2 minus p. Ultimately it will be 2 minus p plus q plus r. So this is your z value. Now same way v minus double. So ultimately pqr pxyz minus yz. It is coming x. X equals to, is clear, xyz minus yz. X will, okay, only one is left, that is x. So you may write p plus q plus r by 2 minus q. Ultimately it is coming p minus q plus r by 2. Same way v minus 3. So if I can add, subtract, then it will be x plus y plus z minus z plus x. So it is coming y. So p plus q plus r minus 2 by r is equals to p plus q minus r by 2. Okay, now you know what is your y, what is your x and what is your z. All are known to you. So please write down, therefore from 4, what you have from 4, that is T inverse PQR is equals to XYZ. What is X? So you need to write P minus Q plus R by 2. This one. And what is Y? P plus Q minus R by 2. What is Z? Minus P plus Q plus R by 2. So this is your required inverse transform. Inverse linear transform. Clear? It's very easy. First you need to write what is your linear transformation of naught. If yes, then you substitute the value. You should consider whatever the number of term you have, you should consider individually PQR. So our objective, different to find T inverse. So our objective to express the variable X, Y, Z in terms of PQR only. After getting it, just you substitute in the relation and that is your required inverse Laplace, inverse linear transformation. Okay. Thank you. Thank you everyone.